To make things simple, I will quickly run through how our 8-litre enclosure works with the regular controller. The controller is interchangeable with our 50-litre enclosure, which I'll show also, and our more specialised CellMaker Plus models with their additional features will be discussed after. Now, let's look at the accessories required for our flagship regular system. Here we have the keyboard and mouse, the 19-pin connector cable. This provides both power to the enclosure and also transfers information to and from the controller. Then we have our gas inlet tubes. This 8mm blue tube provides all gases from the controller to the enclosure, and the 8mm black tube is used to supply an auxiliary gas inlet, typically O2 or CO2, from a compressed tank. Then we have various gas filters to filter the gases coming from the controller, but also the gas leaving the system. As an optional purchase, our systems allow for integration with the peristaltic Watson Marlow pump. This can be used to manually feed media into the system, but also fully programmable through a controller to automate pumping for semi-batch applications. The connections to the back of the controller are very straightforward. We have two power supply cables to be connected, one for controller and one for the screen, which is also linked via HDMI. The gas outlet of the controller also links from here via clear tubing, which connects to a filter prior to the linking with the bioreactor. The gas inlet to the controller is fed from the back. At the back of our enclosure, we have the 19-pin connection, and the other connection is for our condenser unit. This condenser unit can be placed either beside the enclosure, or for our much larger 50-litre units, we have space for them to just sit on top. Each of our bioreactor bags are designed to ensure maximum sterility. They come as shown, where the gamma-radiated sterilised bioreactor bag is placed in an inner UV protectable black sleeve, which is also sterilised. This black sleeve is enclosed by another protective clear sleeve, and this sterile layered packaging has allowed viewers complete flexibility to ensure the bag remains sterile for their cleanroom operations. Our technical application specialists have achieved countless sterile runs in various cleanroom or laboratory configurations and will help you to ensure that you have the procedure tailored for your specific workplace. The bags are made from a combination of low-density polyethylene and ethyl vinyl alcohol. First, we have the inlet gas barger, and this is the driving force of the reactor as it provides gas for mixing, but also gas for cell metabolic requirements. Secondly, we have the media feeding line, complete with an MPC easy connector and a plastic clamp to isolate the bag from the line. And then we have a quick connect female MPX connector, which can be used for optical density probes, and then an inoculation or sampling lure lock port. At the top of the bag, we have an exhaust line which feeds to the condenser unit and 4 inlet ports with the same lure lock mechanisms. Once all connected, the following setup looks like this. We have our gas inlet filter, bridging gas from the controller to the bioreactor. We have the bioreactor bag safely secured in the enclosure, which is easily removable via this plastic panel and locking mechanism shown. We have our inlet lure locks accessible from the top, our gas outlet tubing leading to a condenser bag and another filter. For simplicity's sake, here we're showing how the bag is filled up with water. The tubing from the bag is connected from this female MPC connector. This tubing is then configured with the peristaltic pump as shown. This would of course all be done within a fume cover to minimise contamination. And as you can see, the bag is being filled up as such. We have rough level guides to show how much liquid in the bioreactor can be filled. Our 8-litre bioreactor bags have a capacity range of 3 to 8 litres for full functionality, and our 50 goes from 10 to 50 litres. To begin a run, first switch the machine on, then you select device 1. For device 2 options, it's for our dual controller, which can control 2 enclosures with the 1 controller. So once you log in with your appropriate password, this screen will then show in the main tab. Parameter values set by user. This is where temperature can be controlled by our Peltier units from 16 to 40 degrees with high accuracy. The airflow supplied by the internal fan can be controlled from 2 to 10 litres per minute, and the auxiliary gas line much the same. So for example, if the airflow is set at 5 litres per minute and the oxygen flow is set at 1 litre per minute, the total gas flow to the bioreactor is 6 litres per minute. Alarms. Our devices have been programmed with a series of preset alarms on the sensors fitted for the system for temperature, pressure, O2 flow and airflow. Measured flow rates. which show the real-time flow of both gas supplies. Heating cooling indicator shows how the pelleter units are working at that moment. Sensor measured values, these show the active condition of the bioreactor, and when the run button is pressed, the bubbles will flow as shown. The chart tab allows the operator to see the process parameters in a graphical presentation. The manual log tab allows you to create a CSV file of a time interval of your choice for a specific period when the machine is running. Otherwise, you can obtain the CSV file from the auto log that records information automatically for the entire time that the system is on. The comments tab is to type and record comments at any time during the run. For example, it can be useful to record inoculation time or when samples are being taken. And finally, the recipe tab, and this enables you to create a recipe or a run profile for which the software, when set in recipe mode, will automatically follow. For example, 2 hours into your run you would like a temperature change. This can be preset with the use of this feature. With our plus and low flow models, there are some additional features. We have a built-in dissolved oxygen patch for our bag, which requires a DO cable. We have the pH probing cable, and we have the optional acid-base pump, which can be used to automate pH control in collaboration with the pH probe. The pH can also be automated with the controller through the controlled injection of CO2. The flow rates of the 2 additional gas flows in the Plus model are controlled with the rotometers as shown. They will open and close on command via the software, and the flow rates necessary for your application is configured with the help of our technical application specialists prior to running. The Plus software is being built onto the existing regular software, and as you can see, there is an additional sensor measured values of pH and dissolved oxygen PO2. There is the automatic DO setting, which allows you to automate the optimal dissolved oxygen concentration in the media through gas injection. There is the acid base pump section, which allows dosing limits set by the user. Similarly, there is the automated pH setting, which allows control of the media pH through CO2 injection, common for mammalian cell cultures, or through the acid base pump mentioned, which is common for microbial fermentation. The injection of the nitrogen gas, which can flush the system for anaerobic processes, and other gases can be controlled here. The limits for air and O2 can be controlled in this section. And finally, we have the adjusted alarm system, which can alert users for dangerous pH and dissolved oxygen levels, as well as the standard parameters mentioned. Thanks for watching. If you have any questions, please contact us. We would love to hear from you. Our website is www.selexis.com.